Hello. Well, in the video today, I'll go through the release notes from every major version of the Go language since 1.18 because it's the last one that I've read about. It's been a while since I've used the latest versions of Go, so yeah, I'll be reading them and maybe I'll write some code here just a small draft to know to see what's up those changes. Okay, so let's start with 118. It's a significant release, changes to the language, implementation of the two-chain runtime and libraries. Okay. As always, it maintains a promise of compatibility. In we expect almost all, I like the word almost here, programs to continue to compile. Okay, let's start. The first one, which uh, I'm already used to, is the generics, which are described in a type parameters proposal. I've never read this specific proposal. It's 2021. This is designed for adding the generic parameter in the Go language. Okay. Interesting. This includes major but fully backward compatible changes to the language. Okay, let me read a bit and I'll be back. Okay, I've read through the changes on each version, and the thing is, most of this the release notes are related to specific changes in the Nego standard library, which won't really matter for me now because there are a bunch of things that I'm not even familiar familiarized. So yeah, I'll basically go through. I wrote down like main things that really matters for each version. In 19 and 20, I simply did not find something interesting to think about. But yeah, I'll go through each one of them so I can understand it better. Starting with the generics, there's a tutorial here in the go.dev website, which is getting started with generics. So why not go through it um, and see if I still remember everything related to generics. Okay, so let's jump into it. Introduce the basic of generics. You can declare and use functions or types that are written to work with any of a set of types provided by calling code. In this tutorial, you declare two simple non-generic functions, then capture the same logic in a single generic function. That's nice. You progress through the following sections: create a folder, add non-generic functions, add the generic function, remove type arguments when calling the generic function, and declare a type constraint. Nice. For other tutorials, see tutorials. And let's just check real quick to see. Um, okay, it's not a lot of tutorials. Multi-modal workspace in relation to this, developer RESTful API with Gene. Generics fuzzing, which is already here. And a true of Go. Okay, so let's start it. Create a create a folder, initialize it. Okay, and let's now add the non-generic functions. In this step, you add two functions to each add together the values of a map and return the total. You're declaring two functions instead of one because you're working with two different types of maps. One stores int64 values and one that stores float 64 values. Okay. Write the code using your text editor. Create a file called main.go. We can even do this and this, so we can do it at the same time. And let's start it with package main. A standalone program, as opposed to a library, is always in package main. Okay. Beneath the package declaration, pass the following two functions declaration. I'll write it down, just to, I don't know, to write something because I like it. It's summing int. It receives a map with the key of type string and the value of int64, and it returns a int64 value. Let's close this part. Okay. It's declaring a variable called s. I don't like this name, but okay. Usually Go code uses this weird name for variables, but yeah, what can I do? It's going to sum all the values from m, and we're taking only the values, and it's returning s. Okay, it's a simple function, right? It iterates over the map. Um, why yes? Maybe because of sum, right? But yeah, it makes much more sense for me to write sum here. Sorry, Go language, but I simply can't. V for value. Well, okay. As it we're using just in one line, I'm okay with it, but yeah, I'm not a fan of that either. And now the sum floats, which receives a map of key string and values float 64. It returns a float 64 value. Um, Same thing. Let's go with sum here. Let's iterate over it, just like the previous one, and let's sum every value, then return sum. Okay. Two simple functions. We know what they do. You declare two functions together. Uh, Let me drink some water here real quick. Some floats takes a map of strings to float 64 values. Some ints takes a map of strings to int 64 values. Okay. At the top of main.go, beneath the package declaration, pass the following main function to initialize two maps and use them as arguments when calling the functions declared in the preceding step. Okay, so let's create a function here. It initialize the int map. Oops. So int 64. One is called first and has a value of 34, and the other one is second. It has the value of 12. I think that it's weird for me that uh, that I'm used to JavaScript to add this final comma uh, to the members of this map. But yeah, I can guess get used to it. Let's create a new map. This time with the float 64 value. The first will be 34.98, and the second will be 26.99. Now let's print it. We're using the format package from the standard library. Non-generic sums, generic sums. We're printing a v value and another one v value, which will be exactly the same thing as what is going on here. Okay, is exactly the same thing as that d value, right? Because at least for the first one, because d is a numeral or is it an integer? Well, I don't remember. So let's use v for now. Yeah, and we're sending the sum of ints and sum of floats. There we go. With the floats value. Okay, and now we have our application here. Near the top of main.go, just beneath the package declaration, yeah, I already imported the format package. Save and run the code. Okay, let's run it. Am I in the correct place? Yes, I am. Run go. What? Go run. What the hell am I doing? Main.go, sorry. So non-generic sums 46 and 62.97. Makes sense. Okay, with generics, you can write one function here instead of two. Next, you add a single generic function for maps containing either integer or float values. Add a generic function to handle multiple values. In this section, you add a single generic function that can receive a map containing either integer or float values, effectively replacing the two functions you just wrote with a single function. Great. To support values of either type, that single function will need a way to declare what type it supports. Calling code, on the other hand, will need a way to specify whether it is calling with an integer or float map. To support this, you'll write a function that declares type parameters in addition to its ordinary function parameters. These type parameters make the function generic, enabling it to work with arguments of different types. You will call the function with type arguments and ordinary function arguments. Yeah, I know that. Each type parameter has a type constraint that acts as kind of meta type for the type parameter. Each type constraint specifies the permissible type arguments that calling code can use for the respective type parameters. Yes, I'm basically writing a function with this constraint saying like you can only add numbers. If it is a float or an integer, it's up to you. And that's probably what this tutorial will create with us. While a type parameters constraint typically represent a set of types, at compile time the type parameter stands for a single type, the type provided as type argument by the calling code. If the type argument's type isn't allowed by the type parameters constraint, the code would compile. The code won't compile. Okay, keep in mind that the type parameter must support all the operations the generic code is performing on it. If your function's code were to try to perform string operations on a type parameter whose constraint included numeric types, the code wouldn't compile. Yeah, okay, that makes sense. In the code you're about to write, use a constraints that allow either integer or float types. Okay, beneath the two functions you added previously, pass the following generic function. So sum int or floats, which receives two types here, a comparable type, and a v type, which is an integer or a float. And the map that it receives is from type key for the key and v for the value, and returns the v value. So integer or float. And the code is exactly the same that we wrote previously. Let's type it. Actually, let's just paste it. Interesting. In this code, you declare a sum int or floats function with the two type parameters, k and v, and one argument that uses the type parameter m of type map kv. The function returns a value of type v. Uh, specific specify specify for the k parameter the type constraint comparable. Intend, intended specifically for cases like this, the comparable constraint is pre-declared in Go. It allows any type whose values may be used as an operand of the comparison operator, equal and not equal. Go requires that map keys to be comparable, so declaring key as comparable is necessary so that you can use k as the key in the map variable. It also ensures that calling code uses an allowable type for map keys. Union of types. Okay, no problem. In main.go, beneath the code you already used, paste the following code, which is some in the generics. Let's paste it. Um, and we are calling it using the types string and int and string and float. Run the code. Non-generic and generic sum to the same value. It's nice. Remove type arguments when calling the generic function. In this section, we'll add a modified version of the generic function call, making a small change to simplify the calling code. You remove the type arguments, which are needed in this case. You can omit type arguments in calling code, and the Go compiler can infer the types. Oh, this is nice. I didn't know this to be honest. Note that this isn't always possible. For example, if you need to call a generic function that had no arguments, you would need to include a type argument in the function call. So, as I am calling the function with this map, which is an int type, right? A string as key and a integer as value. The Go compiler can basically infer what type and I am using here. This is nice, really nice. Let's type it again. Let's run it, and yeah, it works. Nice. Declare a type constraint. In this last section, you move the constraint you defined earlier into its own interface so that you can reuse it multiple times. Declaring constraints this way helps streamline the code, such as when a constraint is more complex. You declare a type You declare a type constraint as an interface. The constraint allows any type implementing the interface. For example, if you declare a type constraint interface with three methods, then use it with a type parameter for a generic function. Okay. So we basically create an interface. Okay. Union. Many of the function already have, pass the following generics. Here using the interface number. Okay. I see. There it is. And now we can add here the some numbers. Pretty nice, pretty nice. Um, and now we can add the final call here. And we have now four different results. Nicely done. You've just introduced yourself to generic single, suggested next topics. Okay. And this is the complete code. Nice, I like it. The only thing that I don't really know if is um, is if I have other like symbols that I can use here for different types. For example, um, not just an union, but uh, maybe a specific interface except from a specific one or things like that. I can probably read about it um, in the original paper. Go generics. The wait, what? Golang generics? No. Generics into generics. Golang generics algorithm. When to use generics? It's not. This is not what I wanted. Golang 1.18 release notes. Release notes. Uh, there it is. Type parameter proposal. That's what I wanted. Okay. Interface types uses constraints. There. This is what I wanted. Additional elements restrict the set of type arguments that satisfy the constraint. An arbitrary type, an approximation element restricts to all types whose underlying type. Oh, okay. Approximation element and then union. This might be a little tricky to understand. I can even search. The new element. Underline type is For example, type any string interface the type of set of string, and therefore the type of set any string is the set of all types whose underlying type is a string. This includes the type myString. Okay. And the new syntax will be the first to use. I have no idea how to say this character in English as a token in Go. Okay. Okay. So yeah, there you have it. Generics in Go. I guess I'll continue the other tutorial, so the fuzzing tutorial in the next video. And actually, I'll probably work this myself and see if it's interesting for me to have a video so I can remind me of what I've studied. I'm not sure yet. So we can even check like the other changes except for fuzzing. Strings now have a cut function. I have no idea what this function does. Um, let's just use this and kill this so I can. Actually, there's no need for me to keep this file, right? I have no idea why I am saving this code here. There's no reason for it. So let's check it out. So strings. Jesus, I cannot type. Cut. Cut slices S around the first instance of SEP, returning the text before and after SEP. The found result. Okay. So it's basically a split, but just for one cut. Not const. Sliced is sliced. So this should return. Wait, this returns a slice of strings, right? Um, what's going on? Oh, it returns three things. Jesus, it returns the first part, the second part, and the uh, and if it was found, if the separator was found. Okay, let's just print it. Why not? Printf f. So first, second, and found. First, second, and found. Okay, let's run it. It should be m, and true, right? Oh, I forgot the line break. Jesus, wait. There we have it. First M, second M, and found true. Okay, it's a interesting function. I don't really know why they added it, but okay. New built-in functions min, max, and clear, and for with ints. This for with ints is something interesting, right? Because usually it wasn't possible for us to do something like this. Was it though? Let me check. 22? Is it on 22? Yeah. 22 release version. Uh, yeah, there it is. For I of range 10, for loops may now range over integers. This is funny. I don't remember me not being able to do this previously. Um, but I guess. Wait, unless. No, yeah, it is working. So let's print line I, and why not V? Yeah, let's just print it in the same line. So I and V. Let's use the D here, and let's add the line break. So I and V. What's going on here? Range over untyped int constraint constants permits only one iteration variable. Yeah, well, it makes sense actually. So there you go. 0 to 9. Okay, nice, nice. What else? The built-in functions min, max, and clear. I have no idea what they do. Let me check. So, what is up with you? The min built-in function returns the smallest value of a fixed number of arguments of order types. There must be at least one argument. If t is a floating point type and any other arguments are not a number, min will return not a number. Okay. Can I use the spread operator in Go? I don't think I can, right? Let's create an array. Array. Which is not array. It is a slice, right? So yes, as it is. So it's a slice of type int. 1, 53, 5, 10 actually, 56, 7, 1, 6, and 95. I cannot use the spread operator, right? Yeah, I cannot. Golang spread operator. Unpacking array as arguments. You can use. No, I don't want to do this. Confirm my choices. I don't care for that. Var arg syntax similar to C. Oh, okay. So we can use it. It's not the same thing, but it looks like it is similar. Wait, what? It did not work here. Uh, hmm. My function it's expecting uh, invalid operation, valid use of. Mm, yeah, I don't know why this isn't working. The how to use ellipses in Golang. Let's check this. It's termed in the Golang language is a variadic function. The function that calls the very number of arguments on those variadic functions. So if you have a function called hello, say hello, which receives a number of names, we can use. Well, actually, it sounds like we cannot use it. This simply says that it's a number of um, a number of integers, but it doesn't seem like I can use it. Let's check that Stack Overflow answer again. Great. Stack Overflow is down. This is great. Or my internet is down. Oh, it doesn't really matter, but yeah, it seems like I cannot use this for for a slice of integers. So I guess I'll have to type this. So minimal is this. It should return. Oh, it does. It also returned an error. No, it doesn't. Why? Okay, the printf returns an error. So let's where am I? Oh, here. Let's run it again. The minimum is 1. Okay. Well, it's nice, I guess. Max is the same thing, and clear. I don't know what clear is. Oh, let's check it out real quick. Clear. The max or mean. Here it is. Um. Okay, it doesn't say anything about the spread operator. Okay, what about the clear? Clear? Yeah, it is clear. Clears maps and slices. For maps, clear deletes all entries, resulting in an empty map. For slices, clear sets all elements up to the length of the slice to the 0 value. Okay. Okay. It's nice, I guess. Not even worth typing here. But okay, these were the changes since Go 1.18. I'll see Fuzz in another video. Bye.